Hi friends, very good morning. Welcome to Anu Academy. So let us start today's class. Today's class is very important for us. Today's class we are going to learn trusses and torsion as part of our assistant engineering syllabus conducted by Andhra Pradesh Public Service Commission. Okay, so now let us start today's class. Okay, so if you are having any doubts regarding your exam preparation, if you want anything from our side, we are ready to help you. So please post whatever the information you need for your exam preparation for that is assistant engineering that is conducted by APPSC. Okay, so right friends, now we'll start today's class. Right, today as I told you, today we have planned trusses and torsion. Yeah, now material is ready in front of us. We'll start discussing. Okay, right. Okay, this is trusses. Okay, this trusses is in our syllabus for assistant engineering. Okay, right. As while you're preparing, don't forget that negative marks is there for a assistant engineering conducted by PPSC, right? So keep this point in your mind and start your preparation, right? Okay, now we'll start discussing today's class. Trusses. Okay, yeah, a truss is a structure that is made of straight slender bars that are joined together at the ends by frictionless pins to form a pattern of triangle. Okay, right. Now here we are having one diagram which is called as king post truss. Okay, see, always have a practice of drawing diagrams of related members, engineering members, so that it will be helpful for you to remember the key points while you are attending, while you are writing your exam. Okay, right. Now here we'll see the applications of these trusses. Trusses are usually designed to transmit forces over relatively long spans. Common examples being bridge trusses, roof trusses, transmission towers, etc. Okay, right. Now we'll move in depth. If we want to find forces in all members of truss, then we would prefer the method of joint. In the members of truss, the members are either in tension or in compression. Okay, a truss which satisfies the relation m is equal to 2j minus r is called a perfect truss. Perfect truss. A perfect truss is considered as a determinate structure. As per the assumption of perfect truss, all loadings, external forces on truss act only at joint. All the members of a truss are dash force member. So here we are having four options: 0, 1, 2, 3. So the right one is 2. All the members of truss are 2 force member. Okay, if truss satisfies m is greater than 2j minus r, m such that number of members, j is number of joints, and r number of components of support reactions, then truss is assumed to be dash truss. Here we are having four options. Let us see which is the correct: perfect, redundant, deficient, none of these. So if truss satisfies m is greater than 2j minus r, then the truss is assumed to be redundant truss. Okay, it is redundant truss. All the members are assumed to be weightless, straight, weightless, and straight, none of these. So all the members are assumed to be weightless and straight. Okay, see here, if you see the options, these are called as combination options. So first we are getting a single related option. Second is also a single related option, but here we are getting dual type of related options, that is weightless and straight. So we have to be alert in selecting these type of options in our examination. Next we'll move to method of section, is also called as method of movement, moment of inertia, method of joint, none of these. So method of section is called as method of movement. Okay, now we will continue. Imperfect deficient truss holds the relation. Okay, now we'll see the options. First is m is equal to 2j minus r. Second is m is less than 2j minus r. Third is m is greater than 2j minus r. Four is m is less than j minus 2r. So the correct answer is m is less than 2j minus r. So imperfect deficient truss holds the relation, that is m is less than 2j minus r. Over rigid truss is also called as perfect truss, redundant truss, deficient truss, unstable truss. So over rigid truss is also called as redundant truss. If a joint is formed by three members such that two are collinear and no external force is acting on at joint, then the third non-collinear member is identified as 0 force member, 1 force member, 2 force member, 3 force member. So the correct answer is 0 force member. Okay, so the correct answer is 0 force member. If a joint is formed by three members such that two are collinear and no external force is acting at a joint, then the third non-collinear member is identified as 0 force member. Okay, now we'll start discussing torsion. Okay, right. When a machine member is subject to torsion, the torsional shear stress set up in the member is 0 at both the centroidal axis and outer surface of the member, maximum at both the centroidal axis and outer surface of the member, 0 at the centroidal axis and maximum at the outer surface of the member, none of the above. Okay, see friends, for each and every question sometime we may face a last option that is called none of the above or all the above. So these type of option we have to be very careful in selecting the correct option. Okay, so when a machine member is subjected to torsion, the torsional shear stress set up in the member is maximum at both the centroidal axis and outer surface of the member. Okay, the torsional shear stress on any cross-sectional normal to the axis is dash the distance from the center of the axis. So the torsional shear stress at any cross-section normal to the axis is dash the distance from the center of the axis is directly proportional. Okay, it is directly proportional. The neutral axis of a beam is subjected to zero stress, maximum tensile stress, maximum compressive stress, maximum shear stress. So the neutral axis of a beam is subjected to, here it is zero stress. Okay, it is zero stress. The neutral axis of a beam is subjected to zero stress. Next, at the neutral axis of a beam, the layers are subjected to maximum bending stress, the layers are subjected to tension, the layers are subjected to compression, the layers do not undergo any strain. So at the neutral axis of a beam, the correct option is the layers do not undergo any strain. Okay, the bending stress in a curved beam is 0 at the centroidal axis, 0 at the point other than centroidal axis, maximum at the neutral axis, none of the above. So the bending stress in a curved beam is 0 at the point other than centroidal axis. Okay, so if you are having any doubts, please post in the comments. I will give you reply. Okay, now we'll continue with this class. Okay, the maximum bending stress in a curved beam having symmetrical section always occurs at the centroidal axis, neutral axis, inside fiber, outside fiber. So it is inside fiber. The maximum bending stress in a curved beam having symmetrical section always occurs at the inside fiber. Next we'll move to, if D is diameter of solid shaft and tau is permissible stress in shear for the shaft material, then torsional strength of shaft is written as 5 by 32 d to the power 4 into tau, d log e into tau, pi by 16 d cube tau, pi by 32 d cube tau. So the correct one is pi by 16 d to the power 3 into tau. Okay, if di and e naught are the inner and outer diameters of a hollow shaft, then its polar moment of inertia is pi by 32 into d naught to the power 4 minus di to the power 4. B, second option, pi by 32 into d naught cube minus d naught cube minus di to the power 3, and pi by 32 into d naught square minus di square, and fourth one d by 32 into d naught minus di. So the correct option is pi by 32 d naught to the power 4 minus di to the power 4, right? So if d1 and d2 are the inner and outer diameters of a hollow shaft, then its polar moment of inertia is pi by 32 into d naught to the power 4 minus di to the power 4. Okay. Next, two shafts under pure torsion are of identical length and identical weight and are made of same material. The shaft A is solid and the shaft B is hollow. We can say that shaft B is lighter is better than shaft A. Shaft A is better than shaft B. Both the shafts are equally good. So here the option is shaft B is better than shaft A. Okay, right. Now we'll see here next one. A solid shaft transmits a torque T. The allowable shear stress is tau. The diameter of the shaft is 3 into 16 T by pi into tau. Second one 3 into root 32 into T by pi into tau. Third one 3 into tau 64T by 64T by pi into tau. The fourth one 3 into root 16T by tau. Okay, now the correct option is a solid shaft transmits a torque T. The allowable shear stress tau. The diameter of the shaft is this first one 3 into root 16 into T by pi into tau. This is the correct option. Okay. Next we'll move to the next one. When a machine member is subjected to a tensile stress due to direct load or bending and a shear stress tau due to torsion, then the maximum shear stress induces in the member will be 1 by 2 into root sigma t square plus 4 tau square, 1 by 2 into root sigma t square minus 4 t square, 4 into 1 by 2 into root sigma t square plus 4 tau square. Second option is 1 by 2 into root sigma t square minus 4 tau square. Next under root sigma t square plus 4 tau square and sigma t square plus 4 tau square. So the correct option is 1 by 2 into root sigma t square plus 4 tau square. When a machine member is subjected to a torsion to a tensile stress sigma t due to the direct load or bending and a shear stress tau due to torsion, then the maximum shear stress induced in the member will be this one 1 by 2 into root sigma t square plus 4 tau square. Okay. Next, Rankine's theory is used for brittle materials, ductile materials, elastic materials, plastic. So the correct option is Rankine's theory is used for brittle materials. Guest theory is used for brittle materials, ductile materials, elastic materials, etc. Okay. So we'll read it once again. Guest theory is used for brittle materials, ductile materials, elastic materials and plastic materials. So the correct option is ductile materials, whereas Rankine's theory is used for brittle materials. Okay. At the nuclear axis of a beam, the shear stress is 0 maximum and minimum. So at the nuclear axis of a beam, the shear stress is maximum. The maximum shear stress developed in a beam of rectangular section is the dash. The average shear stress options are equal to 4 by 3 times 1.5 times. So it is 1.5 times. The maximum shear stress developed in a beam of rectangular section is 1.5 the average shear stress. Okay, so that's all friends for today's class. I think all of you understood today's class. Today we have discussed about the trusses and torsion. I think today's class will be very helpful for your AE and AW preparation conducted by APPSC and Telangana State Public Service Commission. Okay, if you are having any doubts, please post in the comments box. I will give you a reply. So if you have not subscribed our channel, please subscribe our channel. Please like and share our channel. Please discuss with your friends regarding the class work going on in our channel. Thank you very much. Thank you for watching.